Here is the story of a missile flight. And here is the actual flight. How high? How far? How fast? How accurate? These are the questions. A vast array of complex instruments search for answers vital to the development of the nation's rockets and guided missiles. And here are those vital answers. Here are the facts. At White Sands Proving Ground, reducing raw missile test data to meaningful units of measure is a task of the Integrated Range Mission, an operational responsibility of the United States Army. On the thousands of square miles of the nation's largest land range, that task begins when Army, Navy, or Air Force missiles are fired. Hundreds of data-gathering instruments are available for recording flight data. Throughout the missile's supersonic flight, intricate electronic systems record information on what is happening, when it happens, and where. Numerous highly specialized optical instruments photograph the speeding missile. Powerful telescopes record the missile's attitude in space and such specific events as booster separation, spin rate, and explosion of the warhead. Ascanius cinetheodolites, like this one, photographically record entire flights. These instruments are high-precision surveying devices fitted with motion picture cameras. The operation over, camera magazines are brought in and the film is processed. The developed film is inspected for acceptability. On the film are the raw trajectory data, which now must be converted to conventional units of measure. On each film frame, indicator dials show the degrees of azimuth as well as the degrees of elevation from the cinetheodolite to the missile. On the lower edge, timing marks are recorded. 2 or more cinetheodolites cover a missile flight from widely separated points. By correlating azimuth and elevation data from film frames shot at the same time, the missile's position in space is computed. The film inspectors check every inch of footage. Were frames skipped by the camera? Are azimuth and elevation indicator dials legible? Are timing signals present? Next, a bore sight film reader measures tracking correction. That is, the distance from the missile image to exact center of the film frame. The tracking corrections feed automatically from the film reader to this telecortex for coding. And a card is punched for each film frame. For each cinetheodolite, 3 decks have been punched. 1 for azimuth data, 1 for elevation data, and another for tracking corrections. After consolidation into single decks, the cards are almost ready to be fed into a massive scientific computer. But first, start cards are added. These cards carry corrections for such factors as curvature of the Earth and unlevel camera positions. The cards are ready. Now the computer must be prepared. Program tapes, such as the one here, previously prepared by mathematicians and punched out on special equipment, are placed upon the high-speed tape reader of the computer. After the program tape is run through, the computer is ready to follow sequenced instructions for computing cinetheodolite data. Each deck carries the data acquired by an individual cinetheodolite during a single missile test. All decks are fed into the computer. In seconds, its immensely complex machinery correlates and combines the data into one final deck. This final set of cards is fed into a tabulator. And again, here are the facts of flight, the data requested by the missile scientists. For example, missile space position throughout flight. Also listed, missile component and resultant velocities, accelerations, trajectory angles, and angular residuals. The final cards may also be used to produce plots of missile flights. Any desired aspect of flight may be plotted. For example, measurements in any dimension of space versus time, or one space dimension versus another. Uprange, integrated range mission, gathers and reduces data from tests conducted by the Air Force Missile Development Center. For instance, from this Matador to this telemetry antenna, data is radioed. The telemetry data is recorded as the Matador continues flight. Data recorded include missile pressures, temperatures, and many other functions. When the tape is brought in from the field, this equipment reads up to 27 different missile functions from a single taped frequency. The data flow rapidly on, from machine to complex machine. Only through the magic of electronics is this job possible. Reduction of missile data by hand would require years and an army of mathematicians. Finally, the reduced data appear on punched cards. The cards are inserted in a tabulator to produce the final listing of telemetry data. Here is what happened to the missile in terms of pressures, temperatures, flow rates, command responses, fuel consumption, and a multitude of other functions. Other systems of telemetry data reduction include quick-look records from recorders and oscillographs. Integrated range mission also collects and reduces data on the accuracy of ground-to-air missiles. Let's watch such a test as seen by the crew of this intercept ground optical recorder, called Igor. Poised, lethal, the Army Nike Hercules awaits her moment of devastation. Miles away at Holloman Air Force Base, the doomed target plane and two motherships head down the runway. Later, radar assists in ground control of the pilotless target plane.
3, 2, 1.
The test is on film. The Igor's job is done. The Igor data is reduced in much the same way as cinetheodolite data. Integrated range mission not only reduces data from the Igors, the cinetheodolites, the telemetry systems, but also from other systems. There's data from radar, from Dovap Doppler, from tracking telescopes, and from fixed cameras. When complete results are in, all data on a given test are assembled into a final report for use of scientists in building missiles that will fly higher, faster, and farther. Yes, from flight till final report. At each step along the way, integrated range mission personnel at White Sands Proving Ground reduce the missile data, and they constantly search for improved methods and equipment to get the facts of flight, the foundation of progress in guided missile development.